Okay guys, today we're going to be reviewing a new strategy for multiplication. It is skip counting on a number line. So we're going to practice kind of two things in one, skip counting and using a number line. So I need you to be focused, follow along with me in your book. Page 179 is where we're starting in your Go Math book. Okay? So Kelsey, can you read the word problem for me?
Wants to make 3 balls of yarn for his cat to play with. He uses 6 feet of yarn to make each ball. How many feet of yarn does Caleb need in all?
Okay. Did y'all hear a key word in there?
In all.
Okay. Now, since we've learned multiplication, we have learned that in all not only means to add, but a quicker way to add is what? To multiply, right? We just learned that yesterday and the day before. We don't want to have to add up 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5. A quicker way would be to do it 7 times 5, okay? So now when you hear this keyword in all, it doesn't just mean to add, it means to multiply, okay? It's just a quicker way to add the same number over and over again, right? Okay? So we have 3 balls of yarn. And he uses 6 feet of yarn for each ball. Okay? Okay, so now let's go through these steps over here. How many equal groups of yarn will Caleb make? So how many groups do we need to make with his yarn?
3.
3, good, because it says he's making 3 balls of yarn. That's your groups. So 3 groups. How many feet of yarn will be in each group?
6.
6. Does that sound kind of like 3 groups of 6?
Yes.
What do you need to find? What do we need to find?
How many balls of yarn does he have to make?
How many feet of yarn, okay? So how much yarn is needed? Okay, how much yarn will he need for 3 balls with 6 in each ball? 3 groups with 6 in each group. How many feet of yarn does Caleb need for each ball? How many feet of yarn for each ball? Anybody, just call it out.
6 feet.
6 feet. Thank you, Kelsey. Y'all don't be shy. Y'all can respond. How many equal lengths of yarn does he need? Okay, so how many groups of yarn does he need? We're just basically repeating what we put up here in the blue box. 3 equal groups, right? 3 equal lengths. So I'm doing 3 groups of 6. Now we're going to practice showing that on the number line. The number line's already given to us. They've already skipped the first skip for us. Pay attention, Javea. You should be writing all of this down. Okay, so we started at 0 and they've already skipped all the way to 6. Okay, so how many skips do you think I'm going to do?
6. 3.
3 jumps of 6. Good, so that's 1 jump. And I'm going to go again. I'm going to count first. So starting at 6, 1, 2, 3, 4, 5, 6. So it should land at 12. Okay? That's our second jump. And now we're starting at 12 and we're going to count 6 more. So that would be 1, 2, 3, 4, 5, 6. We would land at 18. Okay, and we did 3 jumps of 6. So where did I stop at on my number line?
18.
18. So 18 would be my what? What do we call this?
Jumps.
The answer is called?
Product.
Product. Good. What are the 3 and the 6 called?
Factor.
Factors. Now we're getting the hang of it. Okay. How many jumps did we make?
3.
1, 2, 3. We made 3 jumps. How long was each jump?
6.
6. So if I'm doing 3 times 6, that means I'm going to do 3 jumps of 6. So 1, 2, 3 jumps of 6. So how many feet of yarn does Caleb need for his 3 balls?
Oh, 6 is 18.
18. Good. So why do you think we had to jump by 6s on the number line? Why were we jumping by 6? Why were we jumping by 6? Anybody besides Kelsey? No? Why didn't we jump by 4? Kaylee?
The reason of 4 is the question that you said because you had to skip by 6 is because he did 6 feet, but he had to do more.
Good. So we're jumping by 6s because that's how much feet he needed for each ball, right? Okay. So why did you jump by 6s on the number line? Because we need 6 feet for each ball. Okay, does that make sense?
Yes.
So if he only needed 5 feet, we would have jumped by 5 on the number line. Okay, flip the page. You got that down?
Yes.
Okay, we're going to do number 1 together, and then you're going to try number 2.
Because 6 feet.
Skip count by drawing jumps on the number line. Find how many in 5 jumps of 4, then write the product.
For each
5 jumps
ball.
of 4. Okay? So I need to do 5 jumps, but what am I going to skip by when I'm jumping? It tells me I need to do 5 jumps, but what am I going to skip by?
5.
No?
10.
4s. 5 jumps, but I need to jump. My jump needs to be 4 numbers, okay? So if you notice, they've already started it for us. So we go from 0 to 4, 4 to 8. That's 2 jumps. Okay? Now if I'm starting at 8 and I need to skip 4, I would go to 9, 10, 11, 12. Stop at 12 for your 3rd jump.
Then 60.
Okay, good. Then 16.
Then 20.
And then 20. Can we stop there?
Yes.
Yes, because we did 5 jumps and we skipped by 4s.
5 times 4 is 10.
Yep. So if I land at 20, then that means my product is 20. Okay, number 2, 3 groups of 8. So show me what that would look like on the number line. 3 groups of 8. So remember up here I had 5 as my first factor and I did 5 jumps. Okay, so try this one on your own. I'll come around. Okay, let's see what you got. So if it says 3 groups of 8, then that's the same thing as saying 3 jumps of 8. So I'm going to jump 3 times skipping by 8. So my first jump goes from 0 to 8. And then 8 to 16 would have been your second jump. And then 16 to 24 would be my third jump. Okay? So my product is 24. Okay, so we stopped at 24 on the number line, so that is my answer. Okay, so let's look at how number 3 would look a little bit different. 8 groups of 3. Is that the commutative property here when they just flipped the numbers around? 3 jumps of 8, 8 jumps of 3. Am I going to get the same answer? I'm going to get the same answer, but my number line jumps are going to look different, okay? So instead of doing 3 jumps, I'm now going to do 8 jumps. 8 jumps, and then I'm skipping by 3s. Okay, so my first jump goes from 0 to 3. Where would my second jump land?
It will land at 6.
6, good. So that's 2. Then I would go from 6 to 9. Where would my next jump land?
At 16.
Not 16,
12.
12. And then 12, and I would go to what number next? 15, that's 5 jumps. 15 to 18. 21, good. And last jump lands at 24. Okay, so see how the commutative property on these two problems, they just flip the numbers. That's the commutative property. Our jumps and our groups will look different, but our product will still be the same. Okay, now I want you to try. I want you to try number 4, and you are going to write the multiplication sentence the number line shows. Okay. 8 jumps by 3, and our number sentence was 8 times 3. So think about what the jumps and what they're jumping by, and come up with your multiplication sentence. Okay, so let's check and see what you got. For our multiplication sentence, your first factor needs to be how many jumps we made. So this is the number of jumps. Okay? The first factor is the number of jumps. So I'm jumping once, twice, right? 2 jumps, so 2 is your first factor. And then I look down here and I see it started at 0 and skipped to 9. So now it's skipping by 9. 9 would be your second factor. So this is what you skip by. And then obviously your answer is where you land, or where you stop on the number line.
It's 18.
So 18 is your product. Okay? Alright, let's do a couple of word problems together, and then I want you guys to try this back page starting with number 9. Let me zoom out. This back page, 9, 10, 11, and 12 on your own, and then we will check it together. Okay? So before you go on to number 9 and 10 and all those, we're going to do a couple of these on page 181, working on some higher level thinking. Now that we got the steps down, we need to put it in a word problem. Okay? Number 5 says, Erin displays her toy cat collection on 3 shelves. She puts 8 cats on each shelf. If she collects 3 more cats, how many cats will she have? Okay, so we have a little area right here to show our work. So let's first figure out what we're trying to find. I can already see that I'm going to have to do more than one thing because it tells me right here it's a multi-step problem. Okay? So let's think about what the problem is asking us and what it gives us. It says, how many cats will she have if she collects 3 more? So if I collect 3 more of something, what would I do with that? Would I add, subtract, multiply, divide?
Multiply.
Add. If I just add 3 more, or get 3 more, then I'm going to add those 3. Okay, so that's one step. Okay, now let's go up to this first part. It says, Erin displays her toy cat collection on 3 shelves. She puts 8 cats on each shelf. Does that sound like equal groups if I have 3 shelves, 8 on each shelf? Does that kind of sound like the groups of things that we were practicing with yesterday and the day before?
Yes.
Yes. I have 3 groups, 3 equal groups of 8, right? 3 shelves and 8 on each shelf. So 3 groups of 8. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what's 3 times 8? What's 8 plus 8? 16. 16 plus 8 is 24. Okay, but no, we're not done. We haven't added for our second step. So what do I need to do now? What do I need to do now? Now I need to find how many cats she needs to put on the shelf. What about this part right here? Yes, we need to figure out how many cats total, but she has 3 more cats that she put on the shelf. So what do I need to do with those 3 cats? Add them. So 24 plus 3 is 27. Okay. Now I showed my work using equal groups. If I were to use a number line for that, you would have had to draw your own, and you would have done 3 jumps, right? 3 jumps, skipping by 8s. So I would go 1, 2, 3. My first jump would land at 8. What would my second jump land at? What's 8 plus 8? 16, and then I would land at 24. That's if we were using a number line, but I don't really like this strategy if you have to draw it on your own. If they give you a number line and they want you to show your work that way, then use it, okay? They didn't give us a number line, so we did equal groups, okay? Okay, let's try number 6, and this will be our last one we do together. Actually, let's skip to 7. I like that problem better. It says, Sam, Kyra, Tia, and Abigail each have 10 pennies. How many pennies do they have in all? We hear that word again, in all.
Multiply.
I can add them all up, or a quicker way is to multiply. I know one of my factors has to be 10, right? Because I have 10 pennies. Okay, but how many groups am I going to have? How many groups of 10 pennies would I need to make?
4.
Don't just guess. Look at the problem. 4 because there's 4 people. Very good. I have Sam, Kyra, Tia, and Abigail. They each have 10 pennies. Okay? So I want you guys to pick a strategy to show your work. What's a good strategy that you could use? Kelsey?
To multiply, you can use
Okay, equal groups.
Or you can draw
Number line.
yes, or repeated addition.
Repeated addition.
Or your times.
If I have a 10 in there, can I skip count by tens?
Yes.
Skip counting.
10, 20, 30, 40.
Okay, so pick a strategy and show your work. You may be wondering, well, how do I show skip counting? Write down exactly what you're saying in your head. If you're saying 10, 20, 30, that's what you need to write down. Okay, so on this one, if we had done 4 groups of 10, would be 4 times 10. We skip by tens and you would have gotten 40 pennies in all. Okay? Then we were told to go on to the next page and complete these on our own. So let's go over your answers for this. Each bag has 4 snacks and there's 3 bags. So that's 3 groups of 4. 3 groups of 4 means you're going to do 3 jumps of 4. Okay, so let's do 3 jumps and we're skipping by 4. So there's 1, 2, 3. We land at 12, so that means 3 times 4 is 12. Okay, the next one. A cook has 3 boxes of eggs. Each box holds 6 eggs. So that's my equal groups. 3 boxes, so that's 3 groups, and each box holds 6. 3 groups of 6. So that means I'm going to have 3 jumps, and we're going to skip by 6. Okay, so I'm going to start from 0 and go to 6. That's 1 jump, 2, and 3. 3 times 6 would be 18, so D should have been your answer there. Okay, and the last one, or not the last one, second to last. Okay, so number 11. Sorry, I had to pause real quick. Somebody walked into the room, had a question for me. So here we go with number 11. Ashley digs 7 holes. She puts 2 seeds in each hole. Okay, so that sounds like equal groups. 7 holes. 2 in each, 7 times 2. But then you have the second part here that says she has 3 seeds left over. So what that means is, just think about it. She has put all of these seeds, 7 groups of 2, in the holes, but then she has these 3 that are left over. So this last 3 you should have added at the very end, okay? So we're going to plus 3 at the very end. First, we need to figure out what 7 times 2 is. So I do 7 skips of 2. 1, 2, 3, 4, 5, 6, 7. We land at 14, but don't forget you got to add this last 3. 14 plus 3 is 17. So 1, 2, 3. C would be correct. Okay, on the last one, it says Brooke needs 4 lengths of string, each 2 inches long. How much string does she need altogether? Okay, so you have 4 lengths of string. So picture, there's 1, that's 2 inches long. Okay, and there's another one, that's another 2 inches. 3 and 4. Okay, so how many inches of string does she need all together? So we have to add up all of these, or that's the same as doing 4 groups of 2, because I have 4 strings, 2 in each string. Okay, so 4 times 2, you should have gotten 8. D is your final answer. Okay, now make sure you post a picture of this page that we've done together, and then I want you to go into Seesaw and complete the rest of your assignment in there, doing number lines, some word problems, and then you also have a slide in Seesaw that covers vocabulary. Okay, if you have any questions, please let me know, but I look forward to seeing your work in Seesaw.